The ocean covers more than 2/3 of our planet, and much of it is unique or unexplored. Western Australia is blessed with a massive coastline, incredible biodiversity and a high proportion of endemic species. To truly understand the mysteries of the ocean, it's important to piece together research from many different disciplines. The University of Western Australia has brought together their marine researchers into a multidisciplinary integrated research centre, the UWA Oceans Institute. The goal is to bridge the already existing research strengths in oceanography, ecology, engineering and resource management to allow for larger research programs that address science and resource issues. One of the major processes that influences every aspect of marine research off WA's coast is the Lewin Current. Within the UWA Oceans Institute, there are researchers whose work is focused at sites all along this 5,500 kilometre current.
I'm Chari Paterachi from the School of Environmental Systems Engineering.
The Lewin Current is the longest boundary current in the world, extending from Northwest Cape to Tasmania. It brings warmer, low salinity, low nutrient water into the west and the south coast of Australia. This controls all the physical processes as well as the biology and ecology of the West Australian coastline. We use ocean gliders to investigate the many properties of the Lewin Current.
It goes out into the ocean, we release it, and it travels by itself, so it's an autonomous underwater vehicle which we leave out for periods ranging from 1 month to 6 months depending on which glider we use. During that time it goes up and down the ocean up to depths of 1,000 meters and transmits data real time into the lab. By collecting data over years, we can understand how year to year the changes are occurring within the ocean and the biological response, as well as give us some idea of what changes we may expect through climate change.
Near the start of the Lewin Current is the Northwest Cape, the site of WA's booming oil and gas industry.
Hi, I'm Krish Tyagarajan, Professor at the School of Mechanical Engineering at UWA, and I head the Nearshore and Offshore Research Group at the Oceans Institute.
Here we are, in the process of setting up an experiment to simulate sloshing in marine tanks. Sloshing occurs in tanks like they do in a coffee cup, only a lot more severe. This can result in damage of insulation in LNG containment systems. One of the older style LNG carriers is shown here. LNG and oil are also carried through pipelines, which can be influenced by swirling currents around them.
Ningaloo Reef is an important study site as it's been relatively unaffected by anthropogenic influences.
My name's Malcolm McCulloch. I've just joined the University of Western Australia as Premier's Fellow. My job's going to look at the effects of climate change in the marine environment, in particular on coral reefs. And West Australia is a unique place to study this problem because we have corals all the way from Ningaloo Reef up north and beyond that in the Kimberley, all the way down south to Perth. The problem I'm going to look at in particular is the effects of ocean acidification on coral reefs. This affects how corals calcify. The uptake of CO2 by surface waters is ever-increasing problem as the atmospheric CO2 levels are continuing to rise. This is affecting how corals calcify. And by having a large range of corals to look at, this gives us insights into this process. So for the next few years we'll be undertaking coral coring and looking at how corals grow and react to this new threat in terms of calcification processes in corals.
Particularly for Perth's waters, societal context must be considered when developing resource management plans.
Hi, I'm Julian Clifton. I'm a Research Assistant Professor at UWA and I work in the Marine Management and Conservation discipline at the Oceans Institute.
Increasing population and levels of disposable income are leading to heightened pressures on Perth's coastline. The number of recreational boats in the Perth area is projected to increase by 75% to over 80,000 by the year 2025. The development of marinas can lead to loss of nearshore habitat and requires careful evaluation on a case-by-case basis. This underlines the need to engage in long-term marine planning to cater for the needs of all user groups.
The Centre for Marine Futures studies fish assemblage at many WA locations, including the Southern Capes.
I'm Jessica Maywig, Research Professor and Director of the Centre for Marine Futures at UWA and part of a team studying fish and fisheries ecology.
With a splash, a baited video camera system is overboard at our sampling location. Within seconds, it has attracted Samson fish, then coming to rest on the seabed, where it will film for an hour. Schools of silver drummer are common at the Capes, the natural chemicals in their algal diets rendering them poor eating. Once brought back to the lab, we identify each fish to species and measure its length. These data make an important contribution to our understanding of the state of our marine environment and help support management of iconic species such as pink snapper and the endemic West Australian jewfish.
By uniting existing strengths in marine science, the Oceans Institute will ensure that UWA continues to achieve international excellence in marine research. The UWA Oceans Institute is a step forward, a multidisciplinary research environment necessary to understand the intricacies of WA's massive coastline. Through cohesive effort at the whole of university level, we'll be able to make a valuable contribution to maintaining the biodiversity in our resource-rich environment.